Okay.
Thank you for reminding me. All right, so for the 240, the 220 cannot work. So for the 240 can work, but if you check the ratio, the utilization ratio is very close to 1. Yeah, it's always good and safe for your ratio not to be too close to 1. All right, because if there are additional loads that you didn't account for in your analysis, your member might not be able to withstand it when your ratio is too close to 1. But if you go for this one, 0.71, at least the ratio is a bit far from 1. Even if there are some additional loads you didn't put into consideration during your analysis, your member may still be able to withstand it. Because the idea is once your ratio gets to 1, that is the peak of your of the capacity of your member. That's it has gotten to the peak, that this is the maximum strength. Exactly, it has gotten to its maximum strength, to its maximum capacity. So any other additional load, it will just fail. So that's why it's not good to keep your ratio too close to 1. It's always safe to make it maybe a bit far from 1. So this ratio is going to guide you. Okay. So except if you are sure of yourself, so you can go for 240. But I don't think there is nothing wrong with 240 anyway if you are sure of yourself, but I would rather go for 260 if this happens to be a real life design
situation.
Exactly, because I want to sleep with my 2 eyes closed. I don't want something that call will come in from my client and I will be like, structure it to collapse, all those things. So please master this ratio very well. It's very important. So now, the size we used in our modeling is not up to 260. Now we want to change everything to 260. So we click on this section that we want, then we just click on change. Once we click on change, the sizes of the columns will change automatically. So if I click on change now, and I click on yes, can you see to change automatically? Then the same thing goes with the rafter. All the explanations I've made is also applicable to the rafter. 240 cannot work. 240 is what we assumed in our modeling. You can see that 240 cannot work. You can see the red flag there. So portal structure is giving us options of 260. I say portal structure. Autodesk robot is giving us options of 260 and 280. So if you check this 260, it is too close to 1. This is almost 1.
Very close to 1.
So you can't go for 260. It's better you go for 280. Okay, then you click on change, and the sizes will change automatically. Then after that, you close this. Then you now run the analysis again because your status, your analysis status has gone to yellow. So you need to update it by clicking this calculation again. All right, so it's now up to date. So now we need to now do it member by member now. To do it member by member, that's a member verification. You click on this member verification, then you, first of all, you delete all this. Then you click on the list. Remember, we selected, for the columns, we selected 260. This is HEA 260. And the rafters, we have HEB 280. I hope you understand what I'm saying, because this is the initial something that we used, column. So we're not selecting it again. We're not selecting HEA 260. For the rafter, we're not selecting this rafter again. We're not selecting HEB 280. Then we click on this double arrow. Then the bar numbers for all the columns and the rafters will show here. After that, you close. Then you have the same thing here. All the bar numbers for the columns and the rafters. So once you click on the calculations now, then we now have it individually, each column. This is where you now begin to check the utilization ratio. You know, like I said the other time, I said the lower section might work for some columns.
Yes.
Based on the loads on them.
The loads.
Let's begin to check one by one. Check column 1 now. Look at the ratio, 0.54. Look at this other column 5, 0.78. This column 5 must be carrying more loads than this 1, 2, and 3. Look at this column 17. This one is even higher, 0.84. So you can see the, the differences between the ratio. All right. But for me, I think it's okay because I don't think we have anyone that is less than 0.5. I don't think. So this is a nice design because we have the ratio between 0.5 and 0.7. Very wonderful design. Our design is economical and it is safe. Is that clear now? So now we can be sure that, okay, if this happens to be a real life construction and this is a span of 20 meters, that means if you use a rafter of maybe HEB 280, you can be sure that, okay, it can withstand this span without having any column at the center. You know, all these big all that they will tell you, okay, they don't want any column at the center. Do you get it now? So this is how to analyze it to be sure that, okay, this is the right rafter to use. Because the longer the span, the higher the section. All right. So that is all about the analysis and the design. Okay. So we are left with the connection design, foundation design, and how to generate the details. It's a gradual thing. Do it one after the other. I just want to believe you are learning something.
Sure.
All right. So we have come to the end of the class tonight. So do you have any question based on what we have done tonight?
No question for now.
Okay, no question for now. Sorry, I'm trying to save the video. All right, no question for now. In that case, we can end the class. So we'll continue again tomorrow. Same time. So for the software, I don't know, maybe I will try to download the 2023 version and check if I can install it for you. I'll check.
All right.
You cannot be using the student version.
Okay. All right. Thank you. Good night.
All right. Good night.
Yes, sir.
Yeah.